Okay, so today we're going to move on with our functions lesson, and we're going to talk about domain, range, and interval notation. And actually, we'll start with interval notation. So you might have seen this in Algebra 1 even, if you're talking about like a number line, okay? So if I said something like, what do I want to say? X is between -2 and 5, right? So this is telling me that X is greater than -2, but X is also less than 5, right? So again, if you had a number line, right, this is going way back. You got 0, you got -2, you got 5, right? If we have equals 2, that means we put a closed circle, right? If it's just less than, it's an open circle, right? And we're talking about everything in between, so we would shade the middle. Okay, so that's going way back. Now, there's another way to represent this, okay, that's a little easier. So what we use is either parentheses or brackets, okay? So we have brackets, okay, anytime we have an equal to, right? And I use parentheses when it's just the greater or less than. Okay, so if I'm talking about this, -2, right, it's equal to -2. So on this side, I'm going to have a bracket. Okay, and then it's just less than 5. So I'll put the 5 over here with the parenthesis. Okay, and this here is what we call interval notation. Okay, it's a lot easier, especially when we're talking about domain and range, okay, to write this out than this. Okay, and again, we have the specific brackets depending on if it's equal to, okay, or if it's just greater than or less than. Okay, yesterday we talked about our domain being all real numbers, right? So if I had something like x squared, there's nothing preventing me from plugging in anything to the domain, right? So our domain was all real numbers. In interval notation, we show that with a negative infinity and a positive infinity. Okay, so this means I'm covering literally every single number in existence. Okay, I don't know half those numbers, right? They're immensely large, right? But all real numbers is from negative infinity to positive infinity. Okay, so now notice I use the parentheses there, okay, because we cannot equal infinity, right? Infinity is not a number, okay? It's more of a concept, right? So you can't equal something that never ends, right? So anytime you use infinity, okay, you're going to use the parentheses, right? So a combination of everything, right? If I said x had to be greater than or equal to 2, okay, that means 2 is my lowest number, okay? So in interval notation, right, we'd start with 2 on the left side, right? And then I don't have any bound above it, right? I can pick 100, I could pick 1,000, I could pick 2 million, right? So what I'm going to do is I'm going to put the infinity on that side, and I'm going to put a parenthesis there, right? So we'll come back to this if we need to, but this is what we're going to be kind of using the interval notation when we're talking about our domain and range. Okay, so crap, I think I got rid of it. Give me 1 second. I'm going to bring up a file. Never mind. We'll come back. All right. So let's go through the types of different functions, okay, and we'll talk about their domain and range. All right, so first we have linear, right? We talked about this already, but let's just write it down. So we have, all right, y equals mx plus b. All right, so like we said, I'm going to use d and r, okay? D is domain, r is range. For linear, our domain is all real numbers. And I can plug in anything into this x, right? Nothing's stopping me. The range, okay, is also going to be all real numbers, all right? Again, we could also say negative infinity. Oh, that's a sloppy infinity. To positive infinity, right? For both of those. Okay, so that's our first one, and that's pretty straightforward. Just trying to look. I want to make sure I talk about all the different functions. I had a list, but I misplaced it. Here we go. Okay. Okay, then we have quadratics. Okay. Okay, we call this the squaring function, right? If I added anything onto it, plus x plus 2, okay, it would become a quadratic. Our domain, again, there's nothing stopping me from plugging anything in. I have no restrictions on what I can plug in. Now, here, something interesting happens with the range. Okay, if I'm just talking about x squared, I think we talked about this previously. If I just have x squared, okay, yeah, I think I remember this, right? What don't we have as our range? We don't have any negative numbers down here, right? Okay, so for that, okay, our range, we're going to say, is from 0 to infinity. Okay, and hopefully from algebra 2, you remember, if we manipulate this, then we have, okay, we'll talk about this next week a little bit. Right down here, we call that the vertex, right, where it's the maximum or the minimum. So depending on where that is, right, if it moves up or down, if we have a upward facing parabola or a downward facing parabola, right, if I threw a negative in front of that, it would change, right? But we kind of have half of our graph, the range isn't there, okay? So for quadratics, right, the domain's always going to be the real numbers, but the range depends on, if we have anything extra. Right, if you had like an ax plus b or something like that. Okay, so that's quadratics. All right, next along those lines, right, and we can keep going with this, but I'll just do one more. Okay, then we have the cubic. Now, cubic, it kind of goes back to linear, right? They have an odd power, right? If I had an exponent here, it would be a 1, right? So again, we go to our domain is all real numbers, and our range is also all real numbers, okay? Because now I can have negative numbers, right? Negative 2 to the third is negative 8. Here, if I square a negative number, it becomes positive. So that's why we only have positive answers. All right, so for the cubic, okay, we go back to all real numbers. Okay, so those are, the basic polynomials. And like I said, it just kind of repeats itself. So for the fourth, when I have x to the fourth, it kind of acts like x squared. Right, I'll show you a quick picture. I'll just change that to, right? I mean here, right, it just looks kind of like a fatter parabola. It's a little wider down here. if I start, adding stuff to it. Okay, you can kind of see it behaves like that and has that bottom point, right? Sometimes it looks like a W. Let me see if I add another. No, I'd have to play around with it, but we don't have enough time. All right, but x to the fourth would be a W, right? And we'd only have kind of half the graph again. Okay, now for the slightly different ones, right? And again, we talked about this yesterday. Okay, we have our radical. I'm going to do this here, okay? So our normal radical expression is y equals 1 over x, or some number over x. But what we're also going to be looking at is 1 over some kind of function, okay? So it could be 1 over, x minus 1. It could be 1 over a quadratic, x squared plus 2 plus 3x, What did we say our rule was with a denominator? What can we never have in the denominator?
Negative.
Zero. Oh.
Zero, right? The negative is, we'll see that in a second. Okay, so we know that f of x can't equal 0. So here, there's a few things that we can do with the domain. Okay, so I can just say that x can't equal, some number a. I can say that, right? So in this case, it would be 0. Or if I want to show it in interval notation, okay, I can choose any number but that a. So what I do is I start at negative infinity, but I can't go all the way to positive infinity because there's this one number that stops. Okay, so what I do is I stop at a, right? And it's not equal to, I can't equal to, so it's going to be a closed bracket. But now what happens is that's not it, right? I just don't have negative numbers up to a. I also have all the positive numbers after a. Okay, and the way that we can show that it's both of these, okay, is I'm going to put kind of like a big U, okay, and that means, actually, I forget what it technically means, but it means, both of those, okay. So we're going to see this a little. All right, so this is kind of like we're skipping A, right? We're hopping over A, and it's everything else, okay? So if we look at a graph, I think I have one up here. I think this one will work. Nope, that won't work. Nope. Nope. I'll just do this one. I'll fix this. Yeah, this one looks a little different. Let me get rid of the other one. Okay, but here we just have an x in the denominator, so x can't equal 0. Right? Well, here at 0, my graph will never touch that line, right? I don't know if you learned this last year, but we'll be talking about it this year. We call this an asymptote, okay? It's an invisible line that the graph will never cross, right? So here, I have all these numbers to the left, right? And it comes to the right, and it stops, right? If I keep going down, it looks like it touches, right? But if I zoom in, it'll never touch, right? If I look at, I have 0.06, 0.059, right? I can never touch 0. Same thing. Oops, let me zoom out. Same thing up here. Okay, it's a straight line that gets closer and closer and closer to my y-axis. But if I zoom in real far, right, even all the way up at here at 300, I mean, it looks like it's going to be equal to, but you see that little gap there. Okay, so it'll never equal 0. All right. So really all we have to worry about is just the denominator, right? And if we have a function down here, okay, there's a little trick we can use, right? So for example, if I have 1 over 3x minus 5, okay, and I'll let you guys practice this, but what we're going to do is you set the bottom equal to 0, and you solve, right? So we would add 5 to both sides, divide by 3. So for this specific example, x can't equal 5/3, right? Because if it equals 5/3, we get a 0, and that messes everything up. Okay, so for this specific example, my domain, we could just say x doesn't equal 5/3, or I would say negative infinity to 5/3, including, oops, wrong parenthesis, 5/3 to positive infinity. Okay, this might get a little used, you're not used to that. Let me make this look a little better. That's sloppy. Okay. So when we have a radical, it's just one number, sometimes two, depending on, if we have a square down here. But it's specific numbers that we can't equal. Okay, so that's radical. Now the other type that we'll see I just realized I used the wrong word this whole time. That's not radical, my mistake. That's rational. Radical means that we have a square root. My mistake. It's still kind of early for me. All right. So this, I heard the answer before, right? We can't have a negative number. Okay. So I'm also going to put y equals the square root of f of x. Okay. We must all right. And here, like I said yesterday too, I think it can equal 0, right? So that's okay. So for our basic function, okay, our domain, we're going to say goes from 0 to infinity. Now, let's think about the range. If I can't plug in negative numbers, am I going to get a negative number as my answer? Can I have the square root of, 100 is -2 or, -10? Does that work like that? Okay, it doesn't. So our range is also affected, right? And this is the first time that we kind of really see that. Okay, so again, if we have a function underneath, that's going to, manipulate. It's going to transform it. It might, translate it. It might reflect it. Oops. Okay, over to the other axis, right? So as we get further into more complicated expressions and functions, all right, we'll see different results. Okay, but we'll practice that together. Okay, is there anything else with that? No, not really. All right, so let's take a look at some more examples of rational and radical. Unless, does anybody have any questions so far?
I have a question. Where you
What's up?
wrote for the radical one, where you wrote must have, that's the U with the squiggly line?
No. I wrote a 0 and I crossed it out. So just must
Oh.
have x is greater than or equal to 0. All right, so let's take a look. So most of the time they'll just ask you for the domain, okay? But just be prepared to answer for the range. Now with all of this, okay, we can do it algebraically with, numbers and equations, but a super easy way to do it is just to look at the graph. Okay, so as we do these, okay, I'll be referencing their graphs and we can compare the two. Okay, so we're going to find the domain for, so we'll do 2 problems. First, we're going to find the domain for x plus 2 minus 3, and then we'll do all right, so we'll work through these 2 together, and then that'll probably be it for today. Okay. So for here, okay, for both of these, actually, we only have to worry about what's going on with our specific function, okay? This information on the outside, that'll help us if we're looking at the graph, okay, but it's not going to help us with the domain. So our rule here was anything under the radical has to be greater than or equal to 0. So I'm teaching you the hint right away, okay? So what we're going to do is we're going to take what's underneath the square root. I'm going to rewrite it, and I'm going to set it greater than or equal to 0. All right, and now all I have to do is solve for x. How do I get the x alone here? What do I have to do to solve for x?
Subtract 2.
All right, so I would have x is greater than or equal to -2. And there's my domain, okay? That's all we have to do. So I could say the domain goes from -2 to infinity. All right, and again, for anytime we have a square root, okay, it's going to look like this. You're going to have some number going to usually infinity, unless there's some negatives in here, then that messes us up. Okay. Now for this one, okay, it's going to be a similar process. I'm taking what's in the denominator. Okay, this could be anything. This could be a -50, right? I don't care about it because there's no x. And the numerator, it doesn't really matter, right? Now I'm going to set x minus 3. Now this is going to look weird. I'm going to set it not equal to 0. And then I'm just going to solve like we normally do if that was an equal sign. And right, so just like before, right, I got to get rid of this -3. So I add that to both sides. So x cannot equal 3. All right, and again, if I wanted to write that in interval notation, we'd start at -infinity. We'd go to 3. And then we'd start up again at 3 and go to positive infinity. Okay. Any questions about function notation and finding the domain?
Mr. Murray, when will we know that it's not equal
Like this?
to 0? Yeah, like how do we know like the difference?
Anytime you have a fraction, you're going to do the not equal. Anytime you have a square root, you're going to do the greater than.
Okay, thank you.
Okay. All right. Okay. So if there are no more questions, check Google Classroom later. All right. There'll be like, you know, how there was yesterday, maybe 2 or 3 questions just based on this stuff. All right. And then tomorrow,
Mr. Murray.
what's that?
That's a U, right? Next
Here,
to the
yeah.
What does that mean again? Sorry.
Okay, so let me actually look up the formal definition. We use it. I know this. If you draw it upside down, that means intersection. Okay, these are symbols that are used in a branch called logic. Unfortunately, they don't really teach it anymore. You're supposed to learn it in geometry during your proof, like when you do proofs and all that fun stuff. I'm sure you know all of you guys love that. So this is called a union. Okay, I'll write that down. Okay, so sometimes, you know, it's not always just skipping a number. Sometimes there's a big gap, right? So you're saying that this in union with this is the whole answer. Okay, so in our situation, the only thing that's not an answer is 3. Okay, but sometimes you don't have to write this down, but sometimes you'll see something like, from -5 to 2 in union with 10 to 15. Okay, so that means you'll start at -5, you'll go to 2, you'll skip everything in between, but then you'll start up again at 10 and go to 15. Okay, and if this was intersection, that means you're talking about anything that overlaps, right? So there's nothing that overlaps in here. So, but that's a whole nother topic I really don't have time to get into. Maybe if we have time at the end of the year, I'll talk about it. Okay, so just worry about this sign though, the union. Right. Okay, any other questions? All right, so that's it for today. Okay, like I said, just check Google Classroom for the assignment, and then I'll see y'all tomorrow.
Bye.
Okay.
Bye, Mr. Murray.
Bye.
Thank you. Bye.
You're welcome. Have a good one.